Welcome back. It's Mrs. Boots again, and now we have our parent function called a log. And you're like, what? Log? What is that? I mean, wasn't it bad enough we put letters in with math? Now we got a whole word? Yes, we have a whole word. We're not talking about falling trees. Although we do have some examples of logs in real life, which is kind of cool. So logs are actually used on the scales that measure earthquakes. Okay? So all those people out in California or in any area that has earthquakes, they're excited about that because they kind of like to know what's going on with seismic activity. Then, guess what? All you folks who have these wonderful things, guess what? Logs are the curve in your lenses. So, the fact that you can see with these beautiful glasses on your face means that somebody somewhere knew how to do math with logs and designed the lens so that you could see. The equation is such a giveaway. Guess what it has in it? It has the word log. So my equation is a log we're going to put with a base 2 of x. Now, that base 2 may not make sense to you now, but later on, we have a full unit on logs that explains what that base is. So remember the base on exponents? We said it could be 2, it could be 3, it could be 10, it could be 1/2, could be anything. Guess what? On logs, I can make this number anything I need so that I can scale to measure. So my scale to measure lens curves is going to be different than the scale to measure earthquakes. So that 2 is going to change depending on what it is I'm measuring, right? Now, here is the tricky part. We got to plug numbers in. But there's a little trick, okay? Did you know that a log is actually the inverse of something? So square root was the inverse of square, which is a quadratic, okay? Cube root was the inverse of a cube. Super easy. Log is the inverse of exponential. Okay, so whatever I can do with exponents, I can do with logs. That's kind of cool, okay? So remember with cube and cube root, I said they switch, the x and the y switch. Well, if I look at my exponent table, I look for these numbers in the y column. Guess what? The y values are in the x column, okay? So how do I get, that should be positive, shouldn't be negative. Bad teacher, okay? How do I get 1/2? I would use an exponent of -1. How do I get a 1? I would use an exponent of 0. Remember that? The 0 doesn't give a 0 on this one. Same thing here. How would I get an exponent of 2? How would I get a 2? I'd use an exponent of 1. How would I get a 4? I'd use an exponent of 2. So 2 squared is 4. 2 to the first power is 2. 2 to the 0 is 1. Okay, you see? 2 to the -1 is 1/2. So we're working backwards. That's the inverse. We're doing the opposite. We're switching it up. Okay? Now the easy part. Super easy. We're going to put these points on our graph. Easy enough. Okay, so at 1/2, we're at -1. At 1, we're at 0. At 2, we're at 1. And then at 4, we're at 2. You say, Mrs. Boots, you forgot the negative numbers. Guess what? X cannot be negative. You might want to write yourself a note on that one, okay? So X cannot be negative. You cannot have a negative value for X. Even worse, guess what? X can also not be 0. So basically, X has to be greater than or equal to 0. We can't have 0. We can't have negative numbers. That would give us an error, okay? So we have an asymptote. I know you guys are so excited about that word. Along the y-axis. Okay, we have an asymptote. It's not going to cross over into the negative part of the axis. Well, what is it going to do? Let's look at that. So my curve starts down at negative infinity, comes up, and curves over. So it flipped across. That is the log function. Okay? So now let's look at the domain and range. Domain is super easy. Remember, it's all the way to the left, all the way to the right. Well, all the way to the left would be negative infinity. But it doesn't go there because it's not going to cross that asymptote. So where does it stop? 0. It stops at 0, but it doesn't touch it because it can't be 0. So it's a parenthesis. How far to the right does it go? That's the easy part. It goes to infinity. Okay? Now let's do our range. How low does it go? I can't do low. All right, how low does it go? It goes negative infinity. How high does it go? It keeps going up. It's going to positive infinity. So if you look at your exponent parent function, you'll notice that the domain from log is the same as the range from exponents. And the range from log is the same as the domain from exponents. And that's because they're inverses. It switches, just like the x and y's in the table. And this concludes our logarithmic functions of our parent functions. And then we will work some examples.